Hello friends, welcome to today's session. So today we will be discussing some important facts and figures about the water soluble and insoluble inorganic compounds. Now this particular session would be very important those who are preparing for IIT Advanced, where you are going to get the questions from the salt analysis as well. So this particular session would help you in many ways to address water soluble trends of different compounds in journal. So that is very important to mark it here, that we are going to speak the things in journal. Now, as a matter of fact, when I talk of inorganic compounds, they can be covalent, like the one which is having a covalent compounds like phosphine, ammonia, nitric acid, sulfuric acid, HCl and so on. These are covalent compounds, whereas if you talk about inorganic compounds would be made up of some cation and anion. Now we are going to study in this particular session a bit of if I would write the different cations and anions available in +1 +2 syllabi. So there are lot of anions and there are lot of cations, and as a matter of fact in salt analysis you are being given, say for example they pick up cobalt 2 positive along with the sulfite. So they would ask you to identify, would this, out of these cations and anion, what cation and anion is there in this particular inorganic salt. So for that also I am going to make videos where you would see how to analyze in a given compound, how to detect the anion and cation in a given ionic compound. Now, as a matter of fact, based on these combinations, so this cobalt could be cobalt fluoride, chloride, bromide, iodide, hydroxide, sulfate, nitrate, carbonate, phosphate. So from a given cation, lot of anion can be attached, and for a given anion, lot of cations can be attached. So this is very interesting. Now here what I am going to tell you in today's session is that many times you would see this solubility product KSP values in your NCERT. Generally we have the habit of just seeing it and would not seeing it analytically. If you would see it analytically, here one style of question you would get in the paper is that they will give you some for a given cation they would give you some chlorides or hydroxides or phosphates, and they would ask you the solubility, what is the trend of solubility. Here I am not discussing about the trend of solubility. For those I am going to make some other videos as well in this particular series. Here I am letting you know that in general first you should know that what are the anions which when get joined with a cation they tend to have a solubility very less. As a matter of fact, here I do speak here which you feel little uncomfortable with, that whenever KSP value for some compound is given, generally that compound is not water soluble. Just make it a point. When what I'm trying to say here, just see here. When I say that you are being given some let's say fluoride, chloride, bromide, iodide, sulfate, chromate, hydroxides, carbonates, phosphates and sulfides. Primarily you are able to see that there are 7-8 anions for which the KSP values are given. So that means in general these anions when joined to a cation tend to make not a very water soluble compounds. Of course it is always there that if the KSP value is very low it is totally insoluble, and if the KSP value is little higher, partially it get solubilized. In general what I am saying is that you would not find if you have a nitrate of some cation, you would rarely would find its KSP value because they are nearly water soluble. So KSP values when is given for a given cation is showing you that it is not very soluble. As a matter of fact, in journal what I am trying to show you here, which most of you people might not have viewed it that way, that if I will consider fluoride versus phosphate, you would see that phosphate of any cation or if any cation would have KSP value very low. These are having very low, and comparatively this is high. So this in a way shows very beautiful thing that phosphates generally, same is with the sulfides also, these generally when joined with cations they tend to make a compound which is of low water solubility. Now here what I am going to tell you is a small trend or trick which you always keep it with your mind, so that whenever some question would come you have a broader aspect of any given ionic compound. Now here I am writing few things which you should in a A4 sheet, do write it and place it onto your study board. As in when you are moving around, just see into it and it would imprint it in your mind. Almost all salts of sodium, potassium and ammonium are nearly water soluble. Now beautiful it is. Or in general, alkali metal salts are water soluble, but categorically sodium, potassium, ammonium salts are almost of all anions when they are attached with, they are water soluble. Salts of nitrates, chlorates, perchlorates and as a matter of fact acetates, these are also nearly water soluble. So beautiful it is. And similarly, almost all salts of chlorides, bromide and iodide are water soluble. Here you need to remember, except there are three cations which generally would not be water soluble as chloride, bromide and iodide. So these are silver, Hg2 2 positive and Pb 2 positive. As a matter of fact, this would fall under the category of salt analysis group 1. These cations get precipitated as their chloride, bromide or chlorides as they get precipitated, and at that point of time we used to say a small mnemonics to remember this, that aage honge Punjabi. If you could recall, aage honge Punjabi. So Ag stands for silver, H stands for mercury, P Punjabi, P stands for lead. So this is a tip which I shall be making separate video on that, and if you would want, do write and comment on to the channel. So similarly, chlorides, bromide, iodides, except these are water soluble. And similarly, salts of, if I would write here hurriedly, salts of fluoride are almost water soluble except alkaline earth metal cations like magnesium. This we are writing in terms of journal aspect. Make it a point. This is, I am saying it again and again. Along with it, you are also going to get Pb2 positive. Pb2 positive. As a matter of fact, if you would see chloride, bromide, iodides of these cations of fluoride, you would find that the Ksp value is available on that particular table. And similarly, salts of sulfates are not almost water soluble except alkaline earth metal cations. Of that, in particular, calcium 2 positive and then strontium 2 positive, barium and lead 2 positive. So one style of question which I am trying to let you know is, when you come across sulfate, fluoride, chloride, bromide, iodide, nitrate, chlorate, perchlorate, acetate or sodium, potassium, ammonium, these cations or anion, when get attached with the counter ion, they are nearly water soluble with these exceptions. Similarly, if we talk of insoluble compounds, water insoluble compounds, almost most of the salts of if I write sulfides, carbonates, phosphates, oxalate, with here and there few exceptions as well, chromate, these are nearly water insoluble compounds. Of course, here you have except alkali metal, which we have already said, alkali metal salts are nearly water soluble, and ammonium. And similarly, you also have to remember that most of the metal hydroxides and oxides, that means OH negative and O2 negative, these are also nearly water insoluble, except here also you have to write the same thing, except alkali metal and ammonium. And along with it, I should mark it here that Beretta water is water soluble, barium hydroxide. So the point here is, this is the way you can, so these two lists would help you assist many things. That first you need to see in journal what are the compounds as a cation and anion. Any compound are water soluble and water insoluble. Then there is another style of question which I am going to answer it in upcoming videos in this playlist, that if, say for example, hydroxide of alkali metals are given or hydroxide of transition metals are given, then what is the trend? That's a different question. But in general, we are saying hydroxide are water insoluble compounds except for alkali metals and ammonia and that of barium 2 positive. Hope so you liked this particular video. If in case you liked it, do comment on to this and share it with your friends and juniors, so that everyone we are able to make a community of chemistry loving people in as a whole. Thanks a lot. Have a nice day. Stay safe and take good care of yourselves.